welcome back to the Wolfram Tech Conference 2018. I'm Jessie. I'm here just talking to developers and other interesting people using Wolfram technology in very cool ways. And we're actually at the last talk of the conference. And I'm sitting here with Chad, and he's going to tell us a little bit about what he does at Wolfram and sort of what he's doing here at the conference. So take it away.
All right, thank you. Yeah, so I work in the technical services group at Wolfram Research. And what that means is that we take ideas from customers for projects and we implement them. And that could be at a whole bunch of different levels. So we can take their existing code that they've written and they just want to optimize, and we can take that and work on it, clean it up for them, make it run faster, better, more resilient as needed. Or we could take their ideas that they have and implement them in Wolfram language and deliver a final product to them. Mm-hmm. And any level in between of service is what we support for them.
Cool. So what exactly makes customers sort of attracted to Wolfram Technical Services?
Well, from my vantage point, it seems like most of the time the customers have some experience using Mathematica in the past, whether it was in school or they've done it through their office, and they come across some idea that they know could be done really nicely in Mathematica or in any of our Wolfram products, and they're just looking for help to make that happen, to push them in the right direction, or to just kind of take it over if they don't have time to do it.
So do y'all work with specific industries more often, or do you span cross industries?
Yeah, we've had projects from a number of different industries. So education is certainly a big piece of what we've done. But yeah, we've worked with large companies, small companies, startups, any number of different size companies, and across a bunch of different industries, from banks to engineering companies, and any sort of other types of companies I can think of.
Mm-hmm. Cool. So what are some projects recently that you or tech services in general have worked on?
Yeah, so I'm happy to share some of those today. So yeah, I've worked on a couple, but today what I'm going to be focusing on primarily is projects that are related to the general area of three-dimensional geometry. And so the first project I'll talk about is related to this toy that I'm holding here that's on the table.
Oh yeah,
so
these things.
A company called Hypars came to us and suggested, whoa, these things do come off. They were looking for ways to help their customers build structures with this toy. So this is a toy, I don't know, analogous to Lego or something like that, but it's it's shaped kind of like a tortilla chip. There's actually 4 different shapes.
I know, I kind of want to eat one, but...
Yeah, they're very, very pretty, very nicely colored. I've only brought a small sample of them. There's all kinds of different colors and whatnot. But yeah, so these have these interesting shapes, and the interesting feature about them is that you can build any sort of feature that you want if you have enough pieces and enough imagination to build them. And so what the company was interested in is creating a instruction set that's fully three-dimensional, so that as one of their customers is building these structures, they could zoom in on the object, look at it from a different angle, and be able to really understand, okay, where does this new piece come in and how does it fit? And as part of that also, we built a tool for them to build those instructions, which also can be an interesting, GUI of itself, where a user can just start with these pieces digitally and build them up into whatever feature or structure that they want. And I have some examples I can show of that. So yeah, and then maybe I'll back up a little bit and talk about, because there's some technical details, I won't go into too much of those, but so if you can see on the screen here, these are the different pieces that the company makes. So this is the L1, which is the yellow piece that I was holding in my hand. So it's a 4-sided structure. There's a couple of other 4-sided structures that are a little bit more twisted, and then there's a 6-sided structure here. And then there's connectors that hold these together, and the connectors connect on the middle point of those edges. So what we got from the company are these STL files that we can import into Mathematica and convert them into mesh regions. And then as mesh regions, we need to move those in space into the right locations so the pieces fit in the slots and so forth of these connectors as you build them up. So yeah, those are the pieces. And scroll down a little bit here to show a GUI that this is an early version where I was just trying to get a sense of, okay, I have a piece and I'm going to add another piece to it. how do I get this geometry correct? So the original piece we're looking at is this original kind of four-sided L1 piece, and we can add any of the other four pieces. So I can add a six-sided piece to that. I need to pick which of those edges that I want to connect to. So it could be any of those. I'll just pick 3. So that moves the dot indicates which edge I'm going to connect to. And then we have the connector that, most of these connectors have, well, actually there's 2 kinds. So one has 6 slots, one has 4 slots. So this is this has any of the options here, so it's not actually going to be specified. I'm not going to draw it. But so let's say I want to do the 4 slot, and I'm just going to do it at a right angle to this piece. And I click on the button, and this hopefully will show where that new piece looks on here. And this is, also for my development purposes, I wanted to keep track of how these pieces are moved. So this is the Wolfram language expression transformation function, which says how that new purple piece was moved from its original location in the STL file to where it belongs in this.
Yeah, so you sort of have like you can backtrack through maybe and
Yeah. And this project was really interesting to me because this gets a lot more complicated as you add more and more pieces. And then for instructions, what the company was interested in is, if we're building something like an airplane, for example, there are different sub-assemblies of that airplane. So the first set of instructions maybe is related to building the fuselage of the plane.
Right.
Then you have a next set where you're building the wing. And at the end of each of those steps, then you need to join those bigger pieces together. And so
it's just like Legos.
Yeah, keeping track of this geometrically and computationally in Wolfram language took a little bit of effort to do, but the tools that we have here are very powerful and help us to manage that really well. Yeah, and so I'll just scroll down here, and we did build a full GUI for that. I just kind of show a screenshot here of some of the features that we have. So you can add a different color. You can continue adding. In that previous one I was showing, I didn't actually render the connector in the full application. We do render the connectors. And just to show that, one of the interesting things that you can build here is this guy right here. So here is, if I can get it to go. Yep.
So this is one of the many final structures from these collection of pieces?
Correct. So this is an example from the company. So this is a turtle, and if I can rotate it, you can see the green sort of flappers, the brown shell, and the green head there with the. Yeah, the fun thing is the connector pieces kind of look like eyes in this case.
Yeah, they do.
So it gives the turtle a little bit of character. So yeah, and again, you can build, if you go to HiPars's webpage, you can see a number of different examples of things that you can build with this.
Cool. So what are some other, similar types of projects that you
Sure, yeah.
worked on
So
that
let
use
me
geometry?
let me pull up another case. So we did a project for a company called ADA, and in their case, so they have an experimental physical system that they want to basically visualize with Wolfram language. So we built, again, a GUI for them based on our CDF technology. And so
just real quick, what is CDF technology?
So CDF is a computational document format, and so analogous to a PDF, which you would use, open with Adobe Acrobat, for example, to read those. But it's our technology, and it allows you to share Wolfram documents with anybody in the world, and all they have to do is either open it up in the Wolfram Cloud or get the CDF player, which is a free application, open it on their software, and then they can interact with the code that you put together for them.
So it's like the underlying technology for our Wolfram notebook type.
Right. Yeah, and so, in this case, I'll show you here. So this is not their actual application, but I'm just going to show you, an example of the types of things that we could do for them. So in this case, I've imported from the web this I think this is an STL file again of a dog, just as an example, and
it's a pug. So,
a pug, right? And so what the first thing that they wanted to do was, they place some sensors over the object. So we needed to create an interface where if you click on this object, it would place that sensor where the mouse was clicked. And so there's a little bit of computation involved in that. Some of it is provided with by Wolfram language itself. So when you're looking at a three-dimensional graphic like this, when you click, there's an event handler that tells you, basically the intercepts of that box, three-dimensional box that you've done. So now you have a line And the computational part of it is we have a line that we need to intersect with some of these polygons that are in the mesh. So that's part of the code that we put together to solve.
That's pretty cool that you can like manipulate the current notebook you're in sort of just like as like a function and sort of like it's handling it like dynamically as you click it.
Correct. Yeah. So it takes user inputs and does the calculations on the back end. All the calculations, which is quite extensive. You don't see it all, but this is not a simulation, right? This is actual three-dimensional space that we're placing these sensors in. So there is some pretty significant geometrical calculations that are happening. Okay, so and this is the GUI that we put together. So it's again just one piece of the GUI that we built for them. So we wanted to place sensors on this three-dimensional object. So this responds to a mouse click. So if I click anywhere on this dog, if we want to put a sensor, say it's somewhere near its eye, we could do that. And then we could rotate it into any view that we want. And let's say we want to put a sensor on its stomach, which is pretty flat, I guess, but there's another sensor right there. We could put a sensor on his toe, and so forth, as many as we would want to mimic the actual experiment. Okay, and just for visualization purposes, I'll put those there. Again, this is just kind of one step at a time that I'm showing in this notebook. We've actually have assembled this all into a single file that has all the interactivity built together. But yeah, so that's the first step. And then the next step is, in their case, they're reading data from sensors, and then they wanted to visualize that.
Okay.
And so this is what the next demo is doing. And so this is bringing in that dog, so we can look at it a couple different perspectives. So we look at the side views, and you can see where the sensors were placed. Remember, I put one on the stomach and on the foot, somewhere near the eye, and we can again rotate this one to look at whatever view that we want. These ones are fixed. And this is some of the functionality is kind of hidden behind this GUI here, but we have a button here that would connect to the sensors, the actual physical sensors that they have. Then we could start an experiment where in this case, I'm simulating it, so the data is actually generated by Mathematica itself. And
is that sort of the default if it doesn't detect any sensors?
Well, in their case, they have an actual product that they are working with, but let's continue waiting. Oh, hopefully it's not going to disappear. It might have disappeared on us. Oh, it's still spinning. That's good. Live demos, you never know. But yeah, so in this case, so in the actual experiment, what's happening is that, give it one more chance.
Oh, yeah.
Yeah, we might have network issues here, possibly. Yeah, but again, these
okay.
are
It's always a gamble whenever you try to do something.
These are there's a lot going on in some of these sensors. So yeah, we could just ignore this for now, I guess.
But the idea is pretty clear.
Yeah. So and then what happens is that before we start the experiment, the sensors that we placed are black, indicating that the experiment has started. Once we start collecting data, then these are colorized based on some color scale that the user gets to select, and you can see just visually what the different values are coming from the sensors.
Cool. So this is not necessarily about this, but maybe like what's kind of your favorite sort of project? I imagine you have worked on like many projects in tech services.
Yeah.
But what's kind of like your favorite kind of project to work on?
Yeah, that's a good question. Just in general, I get really excited when my customers are excited about their product and about what I'm building. I'm happy to work on any number of different things, but for me, the biggest thing is the people that I'm building it for really care. I'm not just building it for the sake of building it. So they're going to share. These guys are going to share it with their customers.
Right.
Other projects they're going to share with their customers. Sometimes use internally. But yeah, that's something that's fun. I also personally really like taking on new challenges. So before I had started this, I had some knowledge of three-dimensional geometry, but I've learned a lot through this process and very much enjoyed that and enjoyed getting to know the different tools that are in Wolfram language. But yeah, if you ask me anything in the world I wanted to do, that's a difficult question. But yeah, I mean, I'm happy to continue working on geometry, but I have other projects for universities, working on course management systems. That's also pretty exciting and challenging, where the students really care that this thing works, and the instructors really care that it works. So,
what's the most challenging aspect of being a part of Wolfram Technical Services?
Yeah, I think it's really related to the thing I like the most about it, which is that we have customers in many, many different fields, and they come in with an idea, and sometimes I'm not an expert in it. Maybe someone else on my team is,
Right.
depending on how our work situation, project situation is, and expertise. Projects get shifted to whoever is best suited to it. But yeah, the challenge is that people come up with these really challenging ideas and challenging concepts, and some of these, we're pushing, some of the limits of what we've seen done with Wolfram Language and Mathematica, and we, you know, you know, push those limits, and sometimes it works out really well, sometimes it doesn't. But now that then we know, and we branched out in a space that probably no one has explored before, and so that is fun, but it's also a little bit scary sometimes. We don't know if it's going to work as we
Nice.
hope.
Yeah, no, I imagine it's sort of like, client gives you this like huge sort of like very like also maybe sometimes vague like, thing that they want to do, and it's
Yeah.
like not only do you have to, code it and put it together, but you also have to make sense of it too. 'Cause
Right.
It may not be clear
Right,
immediately.
right, and that's a big challenge too. We on our team are generally technical minded. We've mostly been trained as engineers, in some cases physicists, and so we think a certain way. But sometimes customers come in who don't have that technical expertise, but they have a vision of something that they want to be built, and so having that dialogue and working through, okay, here's what's feasible, here's what's hard, here's what I don't know if we can do, is part of the just ongoing dialogue that we have with customers to try to walk them through the step from initial ideas to final completion.
Cool. Well, thanks for taking the time to talk with me. Do you have anything else you want to tell maybe like the viewers about Wolfram Tech Services or any of the projects or the Wolfram language?
Well, yeah, I mean, we are always happy to have new projects, and if you have an idea for us, please contact us. We're definitely open to ideas, and if we can take it on, we'd be happy to do so.
Awesome. Thank you.
Yeah, thank you.
Thanks for joining us.